This is a quick video reviewing how to do linear and quadratic regressions inside of Desmos. So to do a regression, we begin by entering our data table, and we're going to do this in the upper left-hand corner where we have the little plus sign, and it says Add Item. We're going to add a table. Now I'm going to start with a linear regression. So I will type in my points. The points I'm using are 1, 7, 2, 9.5, 3, 13.2, and 4, 16.1. And I can't see where those points are, so in the left-hand side on the bottom left of that box there, we see the little magnifying glass that says Zoom Fit, and if I click that, it will zoom in, and I can see that this is a linear relationship. It might not be a perfect linear relationship where everything is exactly on the line, but clearly these points are showing a linear pattern. So to do the regression, I'm going to use slope intercept form, and to do that, I use Y1 because I need to tell Desmos to look at that table, and that table is labeled X1, Y1. And so if I want Desmos to look at my table, then I need to tell it, hey, I want you to use this table 1. Now, instead of an equal sign, we use a tilde that is found to the left of your 1 on your keyboard, or if you're using the like a phone app for Desmos, you have to open up one of the other, like the alphabet tab to find it. And then we'll do mx, but again, we don't want just x, we want x1 plus b. And now I've got my linear regression. And so my linear regression, I can see the slope is 3.1 and the y-intercept is 3.7. Now, if I were asked to make a prediction with this model, okay, I could type in my equation. So y equals 3.1x plus 3.7. Okay, now that's showing right up on top of the black line there, and that's because I basically typed this in. And one of the things that you can do with that then is take, let me click undo there so that you can see what I did. So in that star or gear wheel, I guess it's like a little gear wheel, it'll say edit list. All right, and then when I do that, it's going to give me some options. So next to my linear regression model, it's going to give me the option of creating a table from that equation. And what that does now is it sets up this table and it gives me any value of x and any value of y. So if I wanted to predict what the value might be, say if x was 10, I can type in x is 10, and it will tell me that the predicted value for that is 34.7. So I can change whatever value I want. I can say x is -8, and so you can go in and edit the table, and that would give you a predicted value. Okay, now if you were looking for an x value that would say give you a given y value, so if you wanted, say, what is the x value where y would be equal to 20, what you can do is you just kind of have to play around with it a little bit. I know when x is 2 down here, that y is 9.9, so I might try x is 4. That's a little bit low. We'll try x is 5. I need it to be a little bit higher. We'll put in 5.1, 5.2, 5.3. 5.3 went a little bit high, so maybe I could try 0.25, 0.26, and you just get as close as you can to the y value that you want. So that would be how we would do a linear regression and then use the model to make predictions. Okay, if I want to do a quadratic regression, so for this one, I have slightly different values. So I'm going to use x is 0 and y is -3. X is 1, y is 0.25. X is 2, y is 7.2, and x is 3, and we have 17.3. And since I've changed my data values, my window now doesn't look quite right. So let's do zoom fit. And this looks like it might be quadratic. Okay, I'm going to use a quadratic regression. You could do a linear regression, see if you could find something that fits. But we're going to do a quadratic regression on this. And so once again, I'll be using y1, and I'm going to use standard form of a quadratic. So we'll do our tilde, and that is ax1 squared plus bx1 plus c, and it will give me my values for a, b, and c. And it looks like my a value is 1.7125, b is 1.6475, and c is negative 3.0275. Okay, now if I want to use that quadratic to make some predictions, I'm going to go ahead and type it in. So 1.7125x squared. Oh, not a z squared. I don't know how that happened. There we go. Plus 1.6475x minus 3.0275. And once again, that should match up very closely with the purple function that I had there, because I just took those numbers off of the parameter tab there. Now, once again, I'm going to change this to a table so that I can make some predictions. You can also do predictions by using the equation itself, but you might find it easier to do this by clicking the little gear and then saying create table, and say if you wanted to make a prediction, say when x was equal to 4, we can delete the x value, type in a 4, and so when x is 4, we would have a value of about 31.0025. If I wanted to make a prediction when x was 10, when x is 10, y would be equal to 184.7975. Now, if you also wanted to go the other direction again, so you wanted to find an x value that would give you a particular y value. So let's say I want the x value that would give me, say, y is equal to 50. Okay, well, it needs to be lower than 10. So we'll try, say, 7. Oh, not low enough. Let's go to 5. 5 is pretty close. And so we want to go a little bit over 5. Let's try 5.5. Nope, that went up too high. 5.2. No, still a little bit high. 5.1. That's really, really, really close. 49.96787. Let's try 1.1. I think I like that. So, so you would just like play around with that until you could find it. Now, it's actually true with a quadratic that there will be 2 x values when you are looking for a particular y value. So if I try some negative values, like say negative 5, that was not quite high enough. Negative 6.2, negative, move my cursor out of the way. Negative 6.1, negative 6.05, 08, 07. Okay, so there actually are 2 x values. You might be wondering, well, how am I supposed to know that? Well, because you know the shape of a quadratic. And honestly, all I'm doing right now is just kind of guessing around till I can find something that would work. Now, in your activity that I'm making this video for, only positive values of x would make sense, okay? Because this activity has to do with diameter and circumference and area, and so it doesn't make sense to have a negative diameter, so you wouldn't need to worry about plugging in a negative x value, okay? You would only work with positive x values, but mathematically, there are negative x values that would work. So I hope this video was fast and just showed you how you would do those regressions, and then how you would use the regression to come up with a prediction.